but we're going to go ahead and look at this one. So question 32 is like what you're going to see in your homework. And this is actually pretty easy to understand. I think it's easier to solve and work with than the last one. Now, when we talk about these, we need to remember the difference between the area and the perimeter. Now, the area is the length times the width. On the perimeter, we just simply add up all the sides. A rectangle has an area that is numerically twice its perimeter. If the length is twice the width, what are the dimensions? So first, let's begin by drawing out our rectangle. So we'll start with a rectangle. And this one's actually going to be substantially easier, I think, than the last one. So we're going to start with a rectangle, and we know that the length is twice the width. Okay. So length is twice the width. And so we're going to call the width now x. So then the length would be 2x, and the width would be x. So when we dimension our rectangle, we've got an x and an x, and then we've got 2x and 2x. So there's our rectangle. And what we're going to be looking at is we're going to be looking at the area, and we're going to be looking at the perimeter. So let's talk about the area. The area is length times the width. So let's go ahead and find that. So length times the width would be 2x times x, which is then simply 2x squared, right? So that's your area, length times the width. We just multiply them together. Is everyone okay with that so far? Now, we're also going to need the perimeter. And the perimeter is the sum of all the sides. And if I sum up all the sides, let's see what we've got. We've got 2x, another x, that makes it 3. 2 more makes it 5. 1 more makes it now 6x. So we've got our perimeter, which is 6x, and we have our area, which is 2x squared. Now, what does it say in the question? Let's read it again to make sure we know what goes where. A rectangle has an area that is numerically twice its perimeter. Find the length. Sorry, if the length is twice the width, what are the dimensions? So we need to find the length and the width at the end. And what does it say here? Area is numerically twice the perimeter. So we know now the area is going to equal twice the perimeter. And we know what our area is. The area is 2x squared. And we know what our perimeter is. Our perimeter is 6x. So we plug them in. And then we'll go ahead and clean this up a bit. So we've got 2x squared equals now 12x. What can we do? Well, we have a 2 and a 12. They both have a what in common again? Looks like they both have a 2 in common, don't they? So whatever we do to one side, we can do to the other. Divide everything by a 2. That's going to simplify this down a bit. And now we've got x squared equals 6x. Is everyone okay with that so far? Right, so we're going to see what we're doing. Now, we still need to set this to 0 because it's an x squared. So we're going to go ahead and set this to 0. And now we've got x squared minus that 6x equals 0. And now we're going to use 0 factor. It's not a normal trinomial, right? This is not a trinomial, but what we can factor out is we can factor an x out. And if I factor that x out, that's going to leave me then with an x minus 6 left over. I am going to get two solutions, but one of the solutions is a trivial solution, and it doesn't make any sense. So one of the solutions comes from here, and that one is x equals 0. The other solution comes from here, and that's x minus 6 equals 0, which is x equals now positive 6. And which one of these obviously is not going to make sense? 0, right? Because you can't have a 0 length of width. It does work because the length and the perimeter are going to be the same, which is 0, and when you multiply by 2, it's still 0, but that's not going to be anything we can use. So the 0 is going to be gone. Now what we need to find is we want the dimensions of the original. And the original, when we go back and look, was 2x by x. So we know now the 6 goes here, so my width is going to be 6. And does it give us a dimension here? Nope, doesn't say anything about length, inches, meters, nothing. So it's just a 6. And the length is twice that, so that's 2 times 6, which is then 12. So what are our units going to be? Our answer is going to be, they're going to be 6 and 12. And we don't have any units, so I don't know whether these are in feet, yards, so we just leave them without a unit now. I do what now?
No, I was thinking there was more on the side.
Nope, that's it. Because all I have to do is plug that 6 in, and one of them is 6, double the other one, you get the 12. And we have no units because it doesn't give us any in the original problem. Let's move on now and try another one. Let's talk about triangles for a moment. And when we talk about triangles, we're going to have to use the Pythagorean Theorem. And the Pythagorean Theorem comes from the famous Greek mathematician Pythagoras. And he came up with this theorem that applies to right triangles. And this is on page 143. And this is the Pythagorean Theorem. And this is the Pythagorean Theorem. And the Pythagorean Theorem, we've got a triangle. It has to be a right triangle, just like this one here. So you have to have 90 degrees at the bottom. And the Pythagorean Theorem says a squared plus b squared equals the c squared. And the c is always the diagonal. So that c is always going to be the diagonal. A and b, it doesn't matter, they're added together, so whichever one is which, you plug them in. But these don't matter so much. What's really important, though, is that c is that diagonal. So whenever we have a triangle, we're going to have to apply that Pythagorean theorem. And some of these may require us to FOIL first, set it to 0. Some are a lot more complicated than others. And I'm going to pick a really easy one to start off with, and then we'll go back and we'll do a more difficult one. The order in which they're in the homework is not necessarily how easy or difficult they are. The easiest one in here is going to be question 38. We'll come back and then do question 36 after that. 36 is a lot more difficult than 38. And then we'll go do 37, because there's a question like 37 in your homework as well. But let's right now focus on 38. This is the easiest one that involves the Pythagorean theorem. And what we're going to work with is we're going to try and build a solar panel. And we have to build a platform for this solar panel. And we want to make sure we get the correct inclination so we get the most possible sunlight for that panel. So what we've got is we've got a solar panel. And Yolanda has a solar panel with the width of 26 inches. To get the proper inclination for her climate, she needs to build a right triangular support that has one leg twice as long as the other. To the nearest tenth of an inch, what dimensions should the frame have? So we know, first off, by looking at that picture, that we have a solar panel. And that solar panel is 26 inches wide. So there it is. Now we know that we want on this one leg to be twice as long as the other. So I'm going to call this leg X, and this one will be twice as much, so that'll be 2X. So one's twice as long as the other. Now what we want to find is we want to find the dimensions of this triangular support. And when we look at it, we see that it's a triangle, and we know that our diagonal is the 26. So that's our C. And then we've got A and we've got B. Doesn't matter which one is which on the A and B. Always, though, make sure that your C is that diagonal. And now we've got A squared plus B squared equals C squared, and that is X squared plus 2X, and use parentheses here, quantity squared, and that's going to then equal 26 squared. So put all the pieces in, the A, the B, and the C, and now we'll clean it up. I put parentheses here because we have to remember to square that 2. So we've got X squared, that stays the same. Now, when we distribute the square through, it goes to each part. So that is going to make that then 2 squared, which is 4, X squared. And that now equals 26 squared. And 26 squared is 676. And now we're going to apply, in this case, the square root property. And we're going to talk about why we're going to use the square root property in a moment. Now, we're not going to have to set it to 0. Why not? Because all the x's are already on the left. And I could put these together here, and that's going to make it 5x squared equals 676. And I can get that x squared by itself because there's no other x's. And I can do that by dividing by 5. Now we need to think about how we get rid of a square. And what's the opposite of a square? We did this back in 1-4. The opposite of a square is a square root. And whenever we take the square root, we add on that plus or minus. And this one actually says it's going to be a decimal. And it specifically tells us to the nearest tenth of an inch. So let's go ahead and find our two numbers, and then we'll talk about which one, again, does not make sense. So how do we do that? Well, we take our 676 first. We're going to divide that by 5. You can either write that number down, or you can keep it stored in your calculator. Either way, we do need to take our square root. So there's the numbers divided out. Now, I'm going to use the answer key, so we keep it stored in our calculator. We want second square. Okay, so that puts your square root up on the screen. Now, we want what we've stored down here. It has an answer button. Okay, see this negative with the sign around it? In blue is your answer. So it's going to keep whatever you have stored. So if I hit second, and then the negative symbol here, that keeps what you've got stored in there already. And then when you hit the answer key, that's going to give you your answer. And that comes out to then be 11 point, if we round, 6. Want that to the nearest tenth. Now, you could have just wrote the number down and then took the square root of it too. Either way, you're going to get the same result. But your calculator, or most calculators do, have a built-in answer. And it's down here. And that just keeps what you've already got stored in your calculator. So you don't have to write it down constantly. We do have 2 solutions. And which one is not going to make sense? Okay, the negative. So we can scratch that one off. And it wants the dimensions of the triangle. So what do we know for our dimensions here? We know one of them is x. And that's going to then be 11.6. The other one is 2x, so we just double it. And that should give us what? 23.2, I believe. Yep, 23.2. And these are in terms of inches. Yeah, it's a lot easier than the last one. Now, if you struggle using the answer key in your calculator, you can also do it like this. Okay, so let's say I don't want to use the answer key. Well, I can just take that 676 and I can divide it by 5. Okay, that's 135.2. And then I can just take the square root, so second square, of that 135.2 and see I get the same result. So if you want to, you can write it down or you can use that answer key in your calculator. But either way, all we have to round it out to is one place. Now that was one of the easier ones. Now we're going to look at the more difficult, which that's going to be question 36. And some of these are easy to set up and solve. Some of them are more difficult. The good thing about question 36 is they give you the triangle to begin with. So the triangle's already done. You've got a person holding a kite on the ground, and he's 5 foot tall, which we'll talk about that in a moment, or hold it at 5 foot off the ground. And that's going to make this triangle here. And we're looking at a kite. So we've got a kite up here on the string. And it's already been dimensioned, which is nice. So the string is 50 feet long. And the height is x plus 10. And the length down below is an x. If we read the question, while you copy this down, it says, Grady is flying a kite on 50 feet of string. So there's your string. That's your solid part there. Its vertical distance from his hand is 10 feet more than its horizontal distance above the ground. Assuming that the string is being held 5 feet above the ground, find its horizontal distance from Grady and its vertical distance from the ground. So that 5, whatever we find for this x plus 10, we're going to have to add 5 to it to get the total height from the ground. But let's go ahead now and just look at our triangle. And this one is already set up, but it is going to be a little bit more challenging to solve because it's been set up, but we're going to have to FOIL. And so this is going to be our C. And we'll call this one our A and this one our B. Doesn't matter which one is which, as long as you're careful and know that the diagonal is your C. So now we know that a squared plus b squared equals c squared. And we can plug our values in. And that's going to equal 50 squared. So we just plugged our values in. That's all we did. And now we're going to have to FOIL. And we're going to have to square. So let's take our x plus 10 quantity squared, and we're going to write it out, and we're going to have to FOIL, because this is eventually going to have to be set to 0. So FOIL this out, and that's going to be an x squared plus 10x plus 10x plus 100, which is then x squared plus 20x plus 100. And then we've got a plus x squared, and then we've got 50 squared, and that should be 2,500, I believe. So 5 squared is 25, and you got the 2 zeros. Is everyone with me so far here? Now, we're going to have to set this to 0, and we're going to combine our terms together. So, see what we've got. We've got an x squared and an x squared, so that makes it a 2x squared. We're going to move that 2,500 over to join the 100. So we've got a 2x squared, and then we've got a 20x, and then we've got a minus 2,400. And that equals now 0. So I just moved everything around. And before we go to factor or do any other work with this, are all the numbers divisible by something? Yep, 2. So always check that first. That is going to dramatically reduce down the work. If it's there, divide it out. It could have been a 3. If that was a 3, a 90, and 3,000, you could divide it by 3. This one has 2, so divide everything by a 2. That is going to make it substantially easier to work with. And now we've got x squared, we've got 10x, and we've got a minus 1,200, and that equals 0. First times the last is going to be a minus 1,200. Let's cover up the zeros and see what we've got. If I cover up my zeros, what do we have here? We have a minus 12 and a positive 1. And we know that the larger number is going to be positive, smaller one's negative. So if I just said 12 and 1, what two numbers are going to multiply together to give you 12, subtract from each other to give you 1? 4 and 3. Okay, so we're going to use a 4 and a 3. Now, what do we have here? Double zeros. So split that up. Look at what we've got now. 40 and 30. 40 times a negative 30 is a negative 1,200. 40 minus 30 is 10. See how I was able to split those double zeros up? Always look at that. If you can do it, split it up that way. That'll save you a lot of time and makes it much easier. Almost finished. Now we've got it to factor. We've got our solutions here. So we've got x plus 40 and x minus 30. And x plus 40 equals 0. So x equals a negative 40. Is that a legitimate solution? Nope, so it's gone. What about the other one? X minus 30 equals 0. So x equals now 30. When we read the question and make sure we find what we need, it says we have to make sure that we find the horizontal distance from Grady and the vertical distance from the ground. So let me go ahead and redraw it, and we're going to fill it in. So we found that to be 50. This one is x down below, so that's 30. And this one's x plus 10. So that's 30 plus 10, which is 40. Now, we need to make sure we take into account the fact that he's 5 foot tall. So let's talk first about the horizontal distance. All right, the horizontal distance is here, and it's that 30, and we are looking at the kite, and the kite is measured in feet on the string. So that means that horizontal distance is also in feet, so that's 30 feet. Now, what about the vertical distance from the ground? Well, the vertical distance from the ground is going to be that 40 plus the fact that he's 5 foot tall. So that's actually going to come out to be 45 feet. Because he's 5 foot tall, we have to add that in. So that kite is actually now 45 feet off the ground. So we answered the question, worked it out completely. Question 37. For question 37, I am going to change it. And I'm going to change it to make it look like what's in your homework. The one in your homework, the sprinkler is actually inside, not outside. The problem is okay, but it really doesn't make a lot of sense. And let's talk about that. If I own some property, let's say it's a restaurant, I wouldn't want to water it this way, would I? Because if I just watered it like this, what would happen? You ended up with some dead spaces there, wouldn't you? Right? And so what happens when they water the lawn? Well, they always spray over. So you get some on the concrete on the edges, but that's okay because all your lawn always gets watered. So let's change that picture to make it look like what's in your homework and make it a better problem. Because the way you would really do this, if you were going to actually go out and water the lawn with the sprinkler setup, you wouldn't set up the sprinklers like this at all. You'd set it up like this. You'd set it up where the lawn is inside, and here's your radius, and this sprinkler would go around. Right? It would look like that, because that's what would make more sense. You see it all the time when you drive by a business. When they've got their sprinklers on at night, what happens? There's water in the street. Why? Because they have to go over a bit to make it work. That sprinkler's going to go around in a circle, and you're going to get some extra over, but you're going to make sure that every bit of that lawn is covered. And that's what it needs to be. So we're going to change it to make it look like this. It's actually an easier problem when you do it. It makes more sense, and it's how your homework is. But now let's read the question. Okay, our diagram is going to look like this instead of the one that they have. So a sprinkler is placed in the center of a square lawn. And the lawn has an area of 800 square feet. The sprinkler is placed at the center so that it sprays the water in the circular pattern as shown. What is the radius of this circle? Ours is different. Ours looks like this. Now everything else is going to be the same. When you look at the lawn is a square. So the lawn is a square, and what do we know about a square? What's special about a square versus a rectangle? Okay, all the sides are the same, so this is going to be x, and this is going to be x. They're all going to be x, right? All the sides are going to be the same. So the lawn is square, so we're going to take our square lawn out, and we know that this area is 800. And what do we know about the area of a square? Well, the area is the length times the width. So that is x times x, which is x squared. And we know now that x squared is going to be what? 800, because that area has to be 800. Now we're going to get the lawn. And once we get the lawn, then we can use the lawn to figure out the length of the sprinkler, how far it needs to shoot the water out. Now, how do we get rid of the square? I'll just rewrite it so it's on the left again. How do we get rid of a square? We use what property? We use the, remember, square root property, plus or minus. And how does that 800 break down? We're not going to use a calculator. We're going to break it down just like we did in 1-3. So 800, well, I can break that down many different ways, but it ends in a double zero, so let's try 100. So that's going to be 8 and 100, and we know that 100 is a perfect square of 10 and 10. So that makes that a little bit easier. So there's part of it. What about the 8? The 8's going to break down more. 8 breaks down into 2 and 4, and 2 and 2. So there's another pair that comes out. So now when we rewrite this, we've got x equals. We're going to keep that plus or minus for right now. And we've got the 2 that came out. We've got the 10. And what's left over that didn't match up with the pair? 2. And that gives us then plus or minus 20 square root of 2. That is then 2 possible solutions. With 2 there. And which one, again, is not going to make sense for us? The negative. So we know it's there. We have to keep track of it because in some cases it might be a viable solution depending upon the application. But in ours, it's not. So we can get rid of that. So now we've got our square, and let's dimension our square and redraw the sprinkler system again. And I'll use the blue to represent the water here, but this is going to go around, right? And I'm just using blue to represent the water. So it's going to go all the way around and spray the lawn. Okay. Now, our goal is to come up with a triangle somehow. And we need to find this piece right here. We can call that R, we can call it X, whatever it needs to be. So we need to find how long we need to make the sprinkler spray. How many feet do I need to adjust the pressure to so that I get enough strength just to barely cover the edge of the lawn and go a little bit into the street behind it? We need to come up with a triangle. So what we can look at is partitioning this into quadrants. So we've got our center right here. And now we can come up with a triangle because this looks like a triangle here. See that little piece of a triangle? Now, once we get that, we're almost done. And the one in your homework is basically the same. Only difference is the numbers are changed. That is it. It is almost identical. Only difference is the area is different. Now let's try to draw our triangle out and try to dimension the triangle, and then we'll take a break after this question. So let's look at our triangle all by itself. So if I look at this triangle all by itself, here it is. Now that's going to be our x, that's going to be our radius. That's what we want. And the length here, well, this entire part is that 20 square root of 2. But we don't look at the whole part, we're only looking at how much of it. Okay, this entire part is 20 square root of 2. So what are we looking at? We're only looking at the upper half, right? So what do you think this would be here on this triangle? Does anyone have any idea? This entire part is 20 square root of 2, and I only want half of it. What's going to go here now?
10.
Yep, 10 square root of 2, right? And same thing on the side, down below. This is 20 square root of 2. We only want half of it, so again, that is 10 square root of 2. Now we finally have everything we need to solve it. So this is my C. This is going to be your A, and this is going to be your B. We've got a triangle, so we can now apply Pythagorean's theorem, find the radius of the sprinkler, and be done. So we've got 10 squared of 2, quantity squared. That's your A. So we got A squared plus B squared equals C squared. So A squared is 10 squared of 2, quantity squared. The B squared is going to be 10 squared of 2, quantity squared. And what is that going to equal? C squared, which is X squared. How do we handle squaring this 10 squared of 2? Well, let's see how that's going to work. So 10 squared of 2, we're going to square it out. I'm going to do this over to the side so you can see what's happening. That square has to be distributed through. So what about 10 squared? Well, 10 squared is going to be 100. Now, what happens when you square a square root? We've talked about this numerous times. When you square a square root, those are opposites. So when you square a square root, it goes away. And that leaves you with that 2. And then 100 times 2 is then 200. Same thing over here again. Okay. Now we're done. We're almost finished. 200 and 200 makes 400. And how do we finish it? Has anyone got any ideas on how we finish it? How would we find our x here? What do we do? Well, we've got the x squared by itself, right? So how do we get rid of a square? Okay, and whenever we take a square root, what do we have to add in? Plus or minus. And we're in luck because what's the square root of 400? Using your calculator, you need to. What's the square root of 400? It should be 20. Right? So second squared, type in your 400, and that comes out to be your 20. So that's going to be plus or minus 20. And we know that one's positive and one is negative, and which one is not going to work? Again, of course, the negative. And what are our units here? It's in square feet for the area. So if it's in square feet for the area, then your radius has to be in feet. So your answer would simply now be 20 feet. So we need to set that sprinkler so that it sprays 20 feet out. And this one is almost verbatim like question 2 in your homework. You do it the exact same way. Draw the same picture, set it up, find the square, work with those pieces, plug it back in, get your final answer. Let's go ahead now and take a short break. We'll come back and we'll finish up this section. This section takes more than any other. And we need to make sure we do at least one or two of each type. That way you can work on your homework.